welcoming to the main stage Anne Mwangi and Sarah Taraporewalla, and they're going to talk about event-driven architecture. So event not being like an event, like a music event, like this, you technologists know all about this. EDA is gaining widespread popularity. Even people like me understand this, as organizations look for ways to simplify the coordination of all of their microservices. Kafka, all of these cool words are coming out despite growing interest in that and the early success of event-driven architecture for a number of people with commercial applications. There's still a big gap between understanding the concepts and actually making it work. So we're really fortunate today to have a couple of people who've leapt that gap, who've gone on stage and made it work. And they'll talk about the challenges they face and the techniques they've used. And, you know, if you're having to go away and talk about event-driven architectures to your stakeholders, this is a talk to really jump into the Slack channel of and see how we're all going. So Sarah is principal technologist at Thoughtworks, specialised in developing robust and sustainable software. That's part of her character and part of her profession. She loves delivering. She's passionate about helping CTOs and architects transform their businesses. And that's the sort of the Thoughtworks thing, this weird crossover zone between passion for business and passion for tech. So she's right in there. A lot of experience doing that terrible thing of modernising legacy platforms. You know, monoliths, microservices, she's literate in both. Anne is a software developer who loves contributing to open source. So speaking at conferences is something that comes along with that. And she's done a lot of that. She loves writing about those experiences. You can find some of those links online. I'll put a couple of them up. And she's an amazing mentor for the next generation. Again, Rails girls, those kind of groups. Loves working with young people, keen to work in technology, which is fantastic because that's part of the responsibility of our generation. Coaching, facilitating sessions, now a lot of that online, of course. Doesn't like sitting on her hands, and a dynamic presenter who is great to have on stage today. And coming to grips with challenging problems is kind of her mastermind topic. So they're going to share that right now for us, and everyone jump on board the Slack channel for them. Welcome from your lounge rooms, where we're very privileged to get a great session from you today, team.
Thanks, Nigel. Hi, everyone. We're going to be talking about event-driven architectures. Now, if you think event-driven architectures, there's only one thing missing, and that is a restaurant, of course. Now, we've got some restaurant people dining at our restaurant. A little waiter with a menu. We also have, in a restaurant, a kitchen with a chef that makes food, of course. Every kitchen needs the stock room with all the ingredients. Very importantly, the pub, the bar. And there's just one more thing missing, which is the cashier's desk. Now that I've got each of my different parts of my restaurant, my little, shall I say, microservices, all defined, doing their own responsibility, the question is, how can we let each of these different services talk to each other? We're going to talk about that and our experiences that Anne and I have with bringing microservices together. And to do that, I need to bring in my friend, Anne. Hi, Anne.
Hello, Sarah. How are you? And I'm really grateful to be here and to be creating our restaurant with you. And so, as Sarah has introduced, we have a couple of microservices that we're going to be talking about. We have the kitchen, we have the waiter, we have the cashier. We even have a stockroom because, of course, our materials, our food stuff is kept somewhere. But then the question is, how are we going to make them all communicate? And there's a way we could do that. First of all, we could have the waiter go to the table and take the order. And then the waiter runs to the kitchen and tells the kitchen, hey, table 26 ordered steak and chips. Then after that, the waiter runs to the cashier and tells the cashier, please add steak and chips to table 26. And then after that, the kitchen is like, hey, come for the food. It comes back for the food. The waiter comes back for the food and picks the food and takes it. But as you can see, there's a lot of moving parts. There's a lot of waiter moving here and there. And this is normally what we have as REST APIs, because this is when the service has to talk to each and every service that it needs something from. But maybe there could be a better way, Sarah.
Yeah, I think so. So how about this? What if the waiter stands at the table and just shouts, "Table 26 wants steak and chips." The kitchen can be standing there listening for the order and then go off and make the steak and chips. The cashier can be listening to that order and automatically add that to the bill. And then when the food is ready, the chef just shouts out, "Steak and chips ready for table 26." And that's when the waiter can go and pick up the actual food directly and give it to the table. Now that is called an event-driven architecture.
Yes.
And that's what we're going to be talking about today. Now, Anne and I have both finished some projects recently that used event-driven architecture. So we went through a lot of questions. We had a lot of questions about how to design the system. Going into it, we both knew all the theory involved and all the terms and had a good understanding of that. But to get that first event published in production, there were a few questions that we had to answer. And we're just going to show you those questions today and take you through our thought process behind how we answer them for our individual context.
Yeah, so today for our agenda, we're not going to give you all the theory behind event-driven architecture, because as Sarah said, we can get that online. What we're going to first talk about, why now? Why is it that we need to talk about event-driven architecture? And then just a brief introduction of our definition for event-driven architecture and some terms that we're going to be using today. Most importantly, we're going to talk about the developer experience and even the team experience as a whole when going through this journey of event-driven architecture. We're going to talk about some cross-functional considerations. Some people call them non-functional. We prefer to call them cross-functional because they're across all the functions. And we'll have, of course, the conclusion, and hopefully we'll have questions. And we do have a slide deck that we're going to put in the Slack channel after this. So you'll get most of the points that we'll be talking about there. So to start us, why? Because event-driven architecture is not new. It's something which is, it has been there for many years. But why now? Why are we talking about it right now?
Yeah, so one of the reasons that we're seeing a lot of people moving towards that event-driven architecture is that the last couple of years, people have been embracing the microservices architecture. And they've been cutting down their monoliths and separating them into single deployable instances running. But then they find that the coordination between all the microservices gets a little bit tricky to handle. An event-driven architecture simplifies that by just allowing the services to easily choreograph between themselves instead of being a directed REST API communication channel. That's one of the reasons we're seeing it. We're also seeing that there is, as we're doing a lot of legacy modernization projects, we're seeing event-driven architectures being used as a way to actually accelerate that transition from the old system into the new. Because you can create an event publisher off your database, as an example, the events can be published into that new services can pick up and start using, while still leaving that data in the existing legacy databases and the legacy systems. So by using that, we can still get early access to whatever's left behind in the legacy system as we create new systems. And the other one is that it leaves data there and available for people to use.
Yeah, and that is something that's going to be the theme for this XConf today. And as Martin and Scott were talking about it, they talked about not only having the data for the data-driven decisions, but also having that explainability aspect. So with events, you don't only have the data that comes out of it, but you can be able to explain the rationale behind the decisions if the time comes for you to do that. And as one of my former colleagues used to say it, that the data and events that you get, they give you ability to ask questions you never even knew that you needed answers to. And that is really strong right now in the way we are living, where software is in the middle of the business. So we need to help the business make the right decisions. And that is why we're going to talk about event-driven in a data conference that we're having today. But before we continue, we'd like to talk about what is event-driven architecture. We're not going to give a long-winded, introduction of what it is, but our working definition for today. And today, what we want to talk about is event-driven architecture and some of the terms that we're going to be using. For example, we do have our microservices, and what we talk about is having a service, for example, the kitchen, which is giving out the events, shouting, steak and chips for table 26, and then the kitchen does not bother what happens after that. It is the work of the waiter and the cashier to respond properly. And so that kitchen, when it shouts that is called the emitter. Some people call it emitter, some people call it the producer, some people call it, the publisher. So we're going to be using these words interchangeably. And also the other service, which is receiving or which listens to the kitchen, for example, the stockroom, if it's listening to what the kitchen says, that's called the listener, or the subscriber, because it might be subscribing, or the sink. Sometimes you hear people talk about it like that. And there is an event stream. That is where we put the events when the kitchen emits or publishes the events. Wherever they go, it's an event stream. Now, one thing we will talk about is that most times we think about a central event stream, for example, when you hear about Kafka and all that, but there are other ways to have an event stream which is not central, and we're going to be talking about that. So basically, emitter, publisher, producer, we're going to be talking about this, but I hope that you understand that. Anything else you want to talk about in the introduction, Sarah?
You know what? I'll tell you what, Ad and I can go for about 10 or 15 minutes talking about all the different terms and what really constitutes event-driven architecture and what's under the umbrella. Instead of doing that, we'll put that one up on Slack, and we've got a couple of explanations that we'll chuck up later in the talk. If there's anything that you really, really want us to explain, chuck it into the questions and we'll be able to pick that one up as we go through. Now that we've talked a little bit about what it is and why, let's talk about some of the questions that we had on our team. Now, the first question that we were faced with, and it's probably a very valid starting point for anybody, is what technology do we use? Kafka is definitely getting a lot of airplay right now, and it's really easy to see why once you start diving into it. You can see lots and lots of things that are even as part of the ecosystem that can really, really help you. The feedback that when we were looking at it though, was that it was fantastic, but also required a little bit of operational ability. So just to operate your Kafka clusters in production, we thought was just that little bit beyond our ability at that moment. We had a team that was suddenly working in Agile. We were moving from an old MFC application to new microservices hosted in the cloud, moving from the data center to the cloud. using Kubernetes for the first time. And there was just a lot of new tech that we were introducing. So instead of adding just yet another layer of new tech come through, we decided to simplify the actual technology that we use and use Event Hub, because they offer Kafka connectors. And so we could do away with the managed, with needing to manage our Event Hub or our event stream, and really start focusing on event modeling, getting our events right, getting our communication between the microservices right. Using the Kafka connectors gave us a good path and a good roadmap to work out how to migrate from the choice that we had to make today for today's circumstances to where we could head in the future when we found that we were comfortable with all the new tech that we had, and that we were suddenly in a place that we were needing to operate with those, like with a huge number of like a fire hose of streams, events from the stream. So that was our choice and for our context. What about you, Anne?
For us, it was the same kind of a situation. We were going to be refactoring an old code base. It has been there for like 25 years, and the company needed to change because of, well, different reasons. But when we came in, it was like we were new to the event-driven architecture way of writing code. And so there was the first thing about, the developers need to start thinking about how events work. And so we thought maybe we will do it kind of gradual. The first point is we were using a backend, which was Kotlin, but in terms of event-driven architecture, we decided to use a framework, and we were using Axon, and we're going to put a link in Slack. We're using Axon as a framework, which did all the heavy lifting, all the events, and how all these things are working together. So at least we didn't have to think about how they worked, and we could concentrate on making, the systems talk to each other. And in addition to that, we didn't have a central event stream. What we had is we used atom feeds. So the producer, for example, if the kitchen knows the producer for this, it will have an atom feed to itself when it produces events. And then the other microservice, for example, the waiter, will just be listening and polling and checking, are there any new events from kitchen? And so we used atom feeds for the polling for the subscription. And first of all, we didn't have to think about having that central event stream. And also we knew that in the future, we could go to Axon server, which will act as that central event stream. But for the meantime, we're able to use atom feeds, and that still gave us, the kind of flexibility that we wanted to first learn how to use event-driven architecture before going to the next complexity. And that was still a good experience using the atom feeds.
So I guess the next question that we had was, what is an event? And how do we group events together? Who gets to own them? Who gets to own the event stream? So we started to think about it like this. If the order is important, and if it's all to do with the same sort of topic, that would be something for the same event stream. So let's go back to our kitchen for a second and think about all of the events that could be passing around the system. Now you can use techniques like domain storming or even service blueprint map to find out what the events are that you need to capture and that go between the system from a business point of view, because that's really what we're hoping for from events. They're not technical things. These are business events that are happening with the system. You can use those same language that you talk about for the events and go directly to your customers, to your users, and they will know exactly what you're talking about. So with our business level events that we're passing through the system in our restaurant, it's all about food and the orders, the stocking, and the bills. Now imagine if our restaurant was actually situated in an RSL. So not only do we have the restaurant, but next door we've got the gaming room. The gaming room with poker tables, with one-armed bandits, with a house. there's not really much of a crossover that's really needed between the restaurant events and with the gaming room. So as a result, you could say that we could group all of the restaurants onto the one stream and allow all of that to come past, so you can get order that's important. The gaming room next door, when you have a new system, a new really domain, that can have its own event stream. And you might every so often publish to a further stream that sort of collects them together. But really, for the context of our restaurant, we'll just use the one stream to group all these messages.
And for us, it was the same. We also had, the same, we had one Atom feed file for each producer because it followed the same kind of a theme, and we were able to, continue with just one way of grouping for each of those events. And it did work for us. But as you said, if we ever expand our restaurant, we can always have another topic,
So the another challenge that we had with our team was that one philosophy that we wanted to have was that our computer could always work in airplane mode. That is, that we could turn off the internet and it would still work. Now that is a bit challenging when you start taking cloud components into the mix. So when things like Event Hub or Kafka start playing an important role as part of the orchestration of your microservices, it's really difficult to get that running locally on your machine without needing to talk to the cloud. We didn't want that. So we wanted our machines just to be able to start up, do some stuff, and then tear everything down. So instead of creating like a dev Kafka Event Hub instance up in Azure, we decided to use a local Kafka Docker image running on our machine. And that meant that you could thrash anything that you want. You could really play around with the modeling of the events, and you weren't going to muck anyone up because the events were just on your machine. That allowed us to really rapidly version our messages as we were working through stories, and gave us that smooth experience where everything was just on our machine and we didn't have to rely on even more infrastructure in the cloud.
But the other thing that we had to think about, yes, we had our development experience very well, and we could develop on our local machines. The other challenge is testing, because as you know, we need to test because we need that safety net. But now the challenge came in because for me to be able to test the kitchen microservice, if I'm implementing something in the kitchen, I need the waiter service to be running somewhere. And if I put everything, if I have to start all the services on my machine, and you can imagine we all write very complicated software, so it will not be optimal. And so we had to decide, first of all, where the test boundaries were, because for example, if it's an ordering, it will go across the kitchen, the waiter, the stockroom, the wait, all of these things. So where do the test boundaries, where are they? And the other thing is, for us, we're quite fortunate because we're in charge of all the microservices as a team. But we've been to other teams where, for example, you own the kitchen microservice, but the rest of the microservices are owned by another team. So how do you ensure that the end-to-end tests are passing? Do you use contract tests, for example, to make sure that if the kitchen service is down, the new as the waiter service, you know what is happening? And so this is something else we had to really think about our boundaries, about our setup, how we're going to do it locally. And I think this is something that all teams need to think about really well.
Yeah. The testing was pretty important decision points for us. And I think looking back, the one piece of advice that I'll give that I really wish I could have given that to myself at the first instance was that you can actually do event-driven architecture without an event stream. You can model your code within a monolith because we didn't start with microservices, we started with a well-factored monolith with the idea that we would eventually break them up. And you could actually model what's happening within events using something like the mediator pattern right from the beginning of building your system, so that when it comes time to plugging in your actual event stream technology, you've got that language of events, or internal events as we were calling them in our system eventually. You've already got them ready to publish to an external system. So we eventually moved our code over to the mediator pattern, where we had commands and events firing internally and being picked up like on the same process internally in the monolith. But when it came time to use the actual event stream, we could easily map those internal events to an external event to publish out as well. And it just made it a lot easier, but we had to refactor our code to get to that position. So if there's any bit of advice that I would have given myself when we started the project, it's if we think we're going to event-driven architecture, there is a model that exists that could be really useful to start with, even if you don't start with your event stream.
Yeah, and that's something also we found out, because like the biggest challenge was having people start thinking in the way of events, because normally we use CRUD, and we know when someone changes an order, we think, oh, update that. But in events, it is add another event. And so that is something we are also challenged with. But thinking about the broader team, not just the developers, the other thing we had to think about is how to slice the work, because we love vertical slices, and we want a story that actually touches from the front end until the very end of the call. But we found out that some of these stories were very big because they were touching different microservices. And so how do you slice the work? This is something that we found very important to talk to the business analysts, to the QAs as they're testing how are we going to go along with this, because we had some never-ending stories and those are not really good. So for us, what we did is that we first at some point, we first worked on the platform, and then we were able to do these vertical stories, which will touch different services. Yeah, it did need a lot of coordination to think about, oh, this goes to this service and this goes to the other service. But eventually we learned, yeah.
Yeah, we had them too, never-ending stories, which are a bane of our existence. We found that because we were also building the platform at the same time as doing feature stories, the feature stories would grow, and we weren't spending enough effort on making sure that we had a production-ready platform. So we ended up splitting the platform work and putting a platform pair or a stream of work in our team to just really focus in on making sure that the platform is ready so that the feature story can just be applied on top. And the main focus that our platform stream had was on our cross-functional requirements.
Yes, and that's what we're going to get onto before we finish. We want to talk about some cross-functional requirements that we had to think about. And the first one which had to come in was observability. Why is observability important? Because in a distributed system, okay, well, even in a single system, it is hard to understand what's happening where. So when it becomes to a distributed system, it is even much more complicated. And so we had to find a way to be able to have that traceability, what's happening in which service and how and when, you know. And the first thing we did after much struggle is have a correlation ID. And this is an ID which we are able to trace a call from one place to the other. And that really helped when we went to look at the logs to understand what is happening. But apart from the correlation ID, Sarah was talking about the log patterns.
Yeah, so we found after we sort of knew that we needed the correlation ID in there, but when we actually came to find out what was happening, why events were going missing within our system, we discovered it was really difficult to search our logs because each microservice was publishing logs in a different pattern. So we ended up streamlining and making just a standard for how the log should appear so that when we had them all in our aggregator, it was a lot easier to pull out the right parts.
Yeah, and having that correlation of logs so that you can understand what's happening everywhere in the system. And this helped us to understand performance, because as you can imagine, as we were starting, the performance was really good before you add all the features. And as you keep adding the features, oh my goodness, the performance just goes down. And it was important for us to understand where and what is happening. For example, one of the challenges we had was we were using event sourcing. And so there were these snapshots. And snapshots at first were being taken after 100 events. And with a big aggregate with a lot of data, that was taking so much time. But when we reduced them to like 10, that was really easy for us. And so understanding the performance and what is happening was really important.
Yeah. Now, I've just had a brief look at Slack and there's quite a few questions there. So I'd like to make sure that we have time for the questions. So I'm just going to say that when you do event-driven architecture, guess what? You get availability and report analytics for free, which is fantastic.
So the other thing we had was the reporting and analytics, which also, it made it a lot easier to have this report, the analytics come through. And because you already have the access to the data. And so in conclusion, Sarah, what do you want for our restaurant today?
Well, very good question. Now that I think that we've already established that we're just going to have the one stream for the restaurant, I like what you were saying about the testing. So I think we will adopt those things for contract testing where we need to, and then end-to-end tests where we can have them within our same team. What do you think about Kafka? Are you ready to try it?
I think at this point I understand enough to try a central event stream. Yes, you can use Kafka. But more importantly, I'd like to think about the cross-functional requirements every time so that, as our system becomes bigger, then we can be able to support more features.
Yeah, I agree. Well, we've had a lot of fun talking about event-driven architecture here today. I could sit here and play with my Duplo for the rest of the afternoon because my kids are out of the house. But if there are any questions, Nigel, have you been monitoring the Slack channel to see if there's any good ones that will throw off our game?
I think you've just set the high bar for questions, that's for sure. I'm noting that Anne's Restaurant, the lights have gone out. It's clearly closing time over there. And, but yeah, look, many questions. Here's one that's from Pradeepa. Are there any design patterns that best suit microservices? Oh, am I in the right channel there? It's event-driven microservices. No, I'm not going to. Design patterns that best suit microservices. I've heard of a Saga pattern. Are we in the right channel there, do you reckon? Does that make sense to you, Sarah?
Yes, we are. Yes, there are a couple of design patterns. What I might do to answer that one, Nigel, is take it onto the Slack channel directly because there's a lot of links and stuff that we can use to discuss that.
And we only have like 3 minutes. Okay, so let's have a look at one here. Okay, here's one from Sajid. How do you address the complexity introduced via event-driven architectures and the asynchronous nature of like coordinating events, debugging?
Yeah. Yes, there is extra complexity with debugging and stuff. And that is one thing that we found a couple of the times events just went missing off our system. But I think with some really good engineering practices, making sure that the logs were kept up to date, that they gave meaningful information to you, that you had tests that were running, and that you could inspect what those logs were, and had tests to automated tests to really load your system to see what was going on before you got into production. We quickly worked out some patterns for helping debug events in production. And the other thing that I would say is, if you want to adopt an event-driven architecture, you have to be completely comfortable with the fact that the world is asynchronous and the world is in inconsistent states with their data, and that your system will be. So it will be quite true that while the restaurant might have already processed the table order, the cashier may not have got around to doing it, and they might do it later. And provided that steak and chips is available on the menu, on the bill by the time the patrons go to pay their order, then the world is fine to be in asynchronous state. So there's a little bit of recognizing that this consistent data notion will get thrown out the window as soon as you adopt event-driven architecture.
Yes, and I hope you can still hear me because my video is a bit frozen. But something that we might discuss on the Slack channel is having tracking processes to help you with the asynchronous. And for us, it came with the action framework that we're using. And so we were able to have a tracking process. So things still continue, but having a tracking process that checks what has happened since the last time that we processed this event, and being able to bundle all those events together and process them. And so that helps you being asynchronous, as well as allowing the system to still continue while you're still processing the rest of the events.
Well, I reckon we might choose one more simple question to go. And from our old friend, Julian Neal, what tech would you choose for giving the front end, web and mobile apps, access to the event bus? You mentioned polling, but what about real-time needs for eventing? Seems like a simple question to me. Choice of technology? What could possibly be hard about that? You too?
Sure. And do you want it, or?
Go ahead as I'm figuring out my video.
I'm going to default to it depends. So on top of your event stream, you can definitely put REST, like a BFF style layer on top of your event stream to do the coordination between your mobile app and the event stream to help funnel those messages to there. We didn't do it for our project, but it was something that we had on one of our future milestones when we brought the mobile app into the picture. It was one of the architectural considerations. But maybe some of our friends on the Slack channel have actually done that, brought the mobile experience, and we can have a good conversation after this on Slack.
Sarah, you're like a magnificent host, because you just exactly segued to what I was going to say, is that there are far too many questions for us to answer. We'd be here all day, but what a great opportunity to be in the channel. Sarah and Anne will both join in over there. You've got a ton of homework to catch up on there, and you too. Thank you so much for that. That's been a great start to the morning.